Morning, everyone. I don't think you really get to clap on Zoom. It doesn't work the same. Oh, you can use your little buttons. That's kind of fun. Hopefully everyone's doing well. You've probably by now gotten used to Zoom and been a little bit used to maybe some of these Zoom workshops and conferences. I actually really like some of the aspects of this because it gives you a chance to attend a lot more of those kind of technical events than you might normally when you, of course, have to make all the travel arrangements and all those kind of things. So I would just like to welcome everyone to this workshop. I'm sure it's going to be a tremendous success. I'm going to start out by sharing some slides and just giving a little bit of a welcome and introduction to University of Kentucky and to my department, Electrical and Computer Engineering. All right, hopefully everyone can see those slides. If you have any trouble, of course, you can chat and send a message to Gia and let her know, and I'll be glad to work on that. So I would just like to welcome everyone to this Neuro-Engineering Workshop with a focus on EEG, and I think we're going to be doing some brainstorming later in the day. I'd like to start out with just a little bit of a welcome to the University of Kentucky. I looked at the participant list just a little while ago. We have over 150 participants from around the world, and really only about a dozen of you are from the University of Kentucky. So I'd like to give just a little bit of welcome. Kentucky, of course, is in the United States, as I'm sure you all know. I'm turning on my annotation, which lets me draw things here. So you can see right here, that's where the University of the state of Kentucky is, right here. It's in the middle part of the United States. We have a very, very beautiful campus. For those of you that haven't been to this part of the country, Kentucky is a part of sort of the Appalachian region of the United States, which is a mountain range over in this area of the country. And it's very, very beautiful, rolling hills, beautiful hiking, and wonderful people, I will say. So University of Kentucky is a great university, and hopefully you'll like it here. So we were founded in 1865. We are the flagship university for the state of Kentucky, one of only a couple of R1 research universities here in the state of Kentucky. We have about 30,000 students here, of whom 23,000 are undergrad and about 7,000 are graduate. And if you look at some of the rankings, for example, the U.S. News and World Report, you'll find we're ranked under national universities about 133. But as I'll show you here in a minute, in terms of our research activity, we're really a little bit higher than that, actually. We have 16 different colleges at the University of Kentucky, which is quite high, a lot of different kinds of programs, more than 90 undergraduate programs, more than 90 master's programs, and over 60 doctoral programs. And one of the claims to fame we have here at UK, we're one of only 8 universities in the United States that has medical program, law program, engineering program, agricultural program, and all of those on a single contiguous campus where we can work together. And that gives us an opportunity to work together across the bounds of, for example, the medical side of campus and the engineering side of campus, right, and the agricultural side of campus. All of us work very closely together, which allows us to solve some problems and work on some problems collaboratively that's a little harder when those programs and colleges are all spread out. So a little bit about our research profile here at UK. Last year, FY20, we had about $429 million in research expenditures. That puts us right about the 90th percentile in the United States. So we are roughly in the top 10% of universities in terms of research expenditures. That $430 million represents more than 1,700 individual research awards to PIs. So we have a lot of research active faculty here. Much of that is on the medical side. We have a lot of those expenses are on the medical side of campus, and a lot of active NIH R1 grants and those kind of things. If you take a look at College of Engineering, where I'm housed, we did about $47 million in research last year, and are again the second highest, I think, after the School of Medicine and the medical side of campus. The university has excellence designations. I think from NIH, I can't remember where those come from, but national designations in the area of cancer, aging, and translational science. Those are all areas of excellence for us. The university has also identified 6 key research priority areas that they have identified, and neuroscience is one of those 6 research priority areas that had nearly $40 million of research expenditures last year. So you can get a little bit of an idea for how our research activities are distributed. Of those 6 priority areas, about 5 of them are in the health area. Okay, so as Gia said, I am the chair in electrical and computer engineering, so I run the ECE department. So I'd like to take this time to tell you just a little more about our programs here in ECE. Some of this relates to medicine and biomedical type applications, some of it doesn't, but I think you'll find it a little bit interesting to see how broad the ECE area is. For those of you that aren't on the engineering side, electrical and computer engineering is a very, very broad discipline that has research in a lot of different areas. In our department, we have over 500 undergraduate students in our 2 programs, electrical engineering and computer engineering. We have between 50 and 100 graduate students in master's and PhD programs, and about 30 tenure track faculty, almost all of whom are active researchers. In the last few years, we have hired 7 new faculty in a wide variety of areas. Dr. Bay is one of those 7 faculty who's hosting today's workshop. And as you can take a look from these areas, that the areas that this includes computer architecture, cybersecurity, power and energy, machine learning, biomedical and robotics, and smart manufacturing. And one of the things I'll point out is that many of these include specifically artificial intelligence and machine learning. So many of our faculty across a wide variety of areas have a strong background in machine learning and artificial intelligence disciplines. So we're really starting to build a strength in that area. These are our core research areas. We have computational electromagnetics, power and energy, computer architecture and cybersecurity, nanotechnology and devices, signal processing, machine learning, and controls, robotics, and manufacturing. And I'd like to tell you just a little bit about each of these 6 areas to give you an idea for what those mean. So computational electromagnetics, I'm sure that's outside of many of your areas, right, on the medicine side, but it has a really strong application that does actually include some medical device applications. Computational electromagnetics is computer modeling of things like antenna patterns and magnetic fields and wave propagation. We have several faculty in this area. To give you sort of a frame of reference, some interesting projects we have in this area include with Office of Naval Research. We have several faculty that use their simulation tools to show what the magnetic fields are going to be around, for example, underwater vessels in changing conditions. And they use very, very sophisticated physics models to do this in real time under dynamic conditions as they change. We also have several faculty that do research with NASA, looking at, for example, things like antenna patterns in the International Space Station. So if you put an antenna on the International Space Station, you need to communicate back to Earth. How are the large metal objects in space and in a vacuum and with atmosphere going to interfere with these antenna patterns so that you can communicate? Our second focus area is nanotechnology. We actually have a very big strength in this. Kentucky and the University of Louisville together house the Nano Integration Node, which is one of 16 National Science Foundation sponsored hubs for nanotechnology across the country. The director of that NNCI program is our own Dr. Todd Hastings, who's a faculty member here in ECE. We have a big strength in nanofabrication. We have a lot of high-tech equipment that's able to do printing at a nanotechnology scale. So we're talking about 10 nanometers, 20 nanometers for certain things. And they can do this with a wide variety of fabrication techniques. To show you an application of this, which does go back to the medical side of applications, many of our faculty have spun off companies and done their own sort of technology transfer from the research lab into practical products. So this is an example of one of those. Dr. Todd Hastings was working on sensors and had a sensor that was able to do good pressure sensing. He started up a company, got an SBIR phase 1, and now is in SBIR phase 2, which is a national, that's Small Business Innovation Research, which is a kind of research funding that promotes technology transfer in the industry. He has a company, Brockman Hastings, that works on developing that pressure sensor into something that measures intraocular air pressure in the eyeball, and it's small enough that it can be inserted in an inpatient procedure into the eyeball for glaucoma sufferers, and they can then use a handheld scanner to check their intraocular air pressure, which allows them to monitor that on a consistent basis. Intraocular air pressure is actually a very large problem for a lot of glaucoma sufferers, and if that gets out of bounds, it can cause them very, very serious vision and health problems. So that's an example of an application in that area. In the cyber area, we actually have a strength in both hardware cybersecurity and software cybersecurity, and we partner with our computer science department in this. In the ECE department, we have a big strength in hardware cybersecurity, which is designing physical circuits that are resistant to malicious attacks and able to be robust in many environments. That's actually a big problem globally. There are adversaries that try to get into the supply chain and supply artificially chips that appear to function correctly but have things embedded in them that allow them to either take control or to gain information. And so what you want to do is be able to secure the supply chain. So an example of a project in this area is our own Dr. Himanshu Thapliyal recently got an NSF Career Award. He does something called adiabatic computing, and they develop hardware systems that are resistant to malicious attacks and will be able to protect against those. We have a huge area in power and energy. This covers actually a lot of different kinds of research. We do motor design, a lot of renewable energy, solar power, wind power, those kind of things. The director of our own Power and Energy Institute of Kentucky was actually used to be a chief scientist at Vestas, which is the world's largest wind turbine manufacturer. Our projects in this area include a lot of federal funding and also a lot of industry funding. So that's a big area for us. Another big area for us is signal processing. And of course, this does start to get back to health and biomedical. We do speech processing, image processing, a lot of virtual reality environments. That does include EEG signal processing, of course, with Dr. Bay does. I have a project in this area myself. I do speech processing and recognition. That is an NIH-funded project where we are using electromagnetic articulography to track the motion of articulators for people with speech dysarthria and try to come up with better rehabilitative systems. That's another example. Our last area is smart manufacturing. We have a lot of faculty in this area, 3 or 4 that have an emphasis in this, including some of our new faculty. And that includes systems to do sort of smart welding and smart manufacturing, and to be able to sort of monitor and extend the life of manufacturing equipment so that this is, so it's high efficiency and that it lasts a long time and is very safe. So, all right, so that's a little bit about the ECE department. Now I would like to talk just a little bit about the neuro-engineering labs that we have here at the University of Kentucky to give you a little frame of reference for our faculty across the different colleges that have expertise in this area. So of course, I'll start out with my own electrical computer engineering faculty, Dr. Jia Bay, who is the faculty member sponsoring today's workshop. She has a neural interfaces and signal processing lab that has expertise, signal processing, machine learning, reinforcement learning, and with a particular emphasis on brain-machine interfaces. She's done a lot of work in brain-machine interfaces, and also quite a bit of work in EEG, and that includes a lot of different kinds of EEG analysis, including functional connectivity analysis, source imaging, and does work with a variety of different applications, including, for example, epilepsy. Second lab I'd like to highlight is the Neural Systems Lab in the Department of Biomedical Engineering. That's Dr. Sridhar Sunderman. He does a lot of different things, computational neural engineering, neural signal analysis for epilepsy, and also does some brain-machine interfaces with an emphasis on rehabilitation. So that's in the biomedical engineering department. And then another lab in the Department of Behavioral Sciences is the Aging Brain and Cognition Lab, Dr. Yang Jiang. Behavior and cognitive science, functional magnetic resonance imaging, ERPs, event-related potentials, and magnetoencephalography, if I can say that correctly. Those are all things that are in this Aging Brain and Cognition Lab, Dr. Yang Jiang. And then the last lab I'd like to highlight is our Cognitive Neuroscience of Aging lab. That's Dr. Brian Gold. They do a lot of work in cognitive neuroscience, particularly for aging and Alzheimer's disease patients, and some neuroimaging, including preclinical Alzheimer's disease. So those labs tell you a little bit about what our expertise is and our abilities here at the University of Kentucky. I'd also like to give you a little bit of an introduction to the various centers and hospital units that we have here at UK that relate to the EEG topic in a broad sense, so that you know kind of what our expertise is. That includes the Magnetic Resonance Imaging and Spectroscopy Center, the Sanders Brown Center on Aging and Alzheimer's Disease Research Center, the Electroencephalogram Lab, the EEG Lab, the Epilepsy Monitoring Unit Center, and the Cardinal Hill Rehabilitation Hospital. Those are all areas, and of course, we've got these web links right embedded in the talk, and Dr. Bay, after the workshop is over, will be posting these slides so you'll have access to the links that are in here. Okay, so last but not least, I'd like to talk just a little bit about the agenda for today and to introduce you to some of the people that are putting on today's talk. I'm going to actually click on this and briefly stop my share and then restart my share in the web, if I can do that. Let's see if that works right. So you should now be seeing the web page for today's Neuro-Engineering Workshop. So you will find a lot of information up here, right? And you can also click on Contact Us if you have questions, registration information. And then under Workshop, you can click on People. There's a picture of Dr. Bay, Dr. Zhang. Benton Girdler is the one that Dr. Bay mentioned you can contact if you have any needs during today's conference that are technical issues. And Dr. Cassie Rogers, who right here in ECE is the event coordinator for today, and she can help you with things as well. And those email addresses are right here on the web page. So if you want to pull up the web page for today's workshop, there's a lot of information that you may need about today's events. Here is the agenda for today. Of course, we're just getting started. The first talk is going to be by Dr. Anna Poos from Indiana University in just a few minutes. That is everything that I have. I would like to open it up in case anyone has any questions about any of the things that I have presented here today before I hand it back to Dr. Bay. I know we have a lot of people on the call, but feel free to post a question in the chat window or ask me a question directly. Just unmute yourself if you have anything. I have found that the number of questions is awfully inversely proportional to the number of people on a call. So the more people there are, the fewer questions you get. Kind of funny. All right, well, thank you. I hope everyone has a wonderful workshop today. I'm sure it's going to be a great success. I am going to hand it back over to Dr. Bay, who I think is going to introduce our very first speaker. Dr. Bay?